Hello, students. Today we're going to study Newton's laws of motion, one of the most important chapters for JEE mains and also advanced. A lot of direct and indirect questions come from this topic, not only in mains and advanced, but also some other engineering entrance tests. So let's start. In the topic of kinematics, you must have studied about motion, like the rolling of this ball. But in this topic, laws of motion, we're going to study the cause of this motion. So we're going to answer, how does motion take place? Suppose that we have a box which had an initial velocity u, and after some time the velocity changed from u to v. So what do you think is the cause of this change? Yes, there must be some force that is being applied. So, in this chapter, we are going to study about force. Force has some types. First, we have non-contact force. Then we have contact force. Next is weak force. And the last is nuclear force. Non-contact force, as the name suggests, is when two bodies applying force on each other are not at all in contact, like gravitational force. Contact force is when two bodies are in contact with each other, like tension, normal reaction, spring, and friction. All these contact forces we are going to study in this chapter. Weak forces, as the name suggests, are the weak intermolecular forces or van der Waals forces. Nuclear forces are the forces inside the nucleus. First, let's study about gravitational force or weight, as we call it. Any object with mass has weight. A body with mass m is attracted towards the Earth's center with the force W is equals to m into g, where m is the mass and g is acceleration due to gravity. Next, let's study about normal reaction. Normal means perpendicular. So suppose there is a box kept on the floor. Gravity must be pulling it towards the center of the earth with a force W is equals to mg. But you observe the box is still not moving. There is a force that is being applied on it, but the box is not moving. This means that a force opposite to W must be applied on the box, which is preventing this movement. Where do you think is this force? Yes, this force must be applied by the ground on the box in this direction. Then only it can prevent the force in the downwards direction. This force is called normal reaction N, and this force is always perpendicular to the point of contact. Always remember this point. Next, we're going to study about tension. Tension T is always applied only on strings, rods, and chains. Suppose we have a mass attached to a string whose other end is attached with a wall. The mass must be pulled by Earth towards itself with the force W is equals to mg, which is also its weight. But the mass is still not moving. There must be an opposing force that is preventing this movement, which is in opposite direction. That means it is in this direction. Always remember that the direction of tension is away from the point of contact. This opposing force is called tension. The tension changes as the string changes. If we have a separate string attached with the same mass, the tension in both the strings would be different. The tension in a string remains the same till the string is same. That is, the string is massless. Now let's try marking the direction of tension in this body. We have a mass m box which is attached to a string and is being pulled with the force F. What do you think is the direction of tension? Remember the points that we discussed earlier. Yes, according to the first point, the direction of tension is always away from the point of contact. This is the point of contact. This means the direction of tension would be in this direction. Now try out the direction in this system. Here we have two separate strings. Now keep in point the second point we studied. The tension is different in different strings. So here we have a force F that is being applied on this string. Let's consider this string to be S1 and this string to be S2. So a tension is being applied away from this point of contact in this direction, and we will call it T1. We also have a point of contact here, but carefully, the string has changed. This means the tension will also change. This tension will be called T2. Here, the complete string is same. This means for this point of contact, the tension would be in this direction, which is same as the previous one, T2. Now, try marking normal reaction in this system. Here we have a wedge and a box. First, just try to locate the contact points because as we studied, the normal reaction is only considerable on contact points. Here we have three contact points. First is this one, second is this, and here we have the third. Now try to mark the direction of normal reactions on your own. Take some time. Let's check it out. So the point of contact is this. This means the normal reaction would be in this direction. Here, the point of contact is this. So the normal reaction applied by wedge on the box would be in this direction, and by the box on the wedge would be in this direction. They both are perpendicular to the point of contact. Over here at the third point of contact, the normal reaction applied by the wall on the box would be in this direction. So we have marked all the different normal reactions. Next, let's check out free body diagrams or FBDs. For FBD, we have three major rules which define FBDs. First, all the bodies or masses are assumed to be point masses. Second, we have to show all the forces acting on the body, not the forces by the body. Third, we have to set a frame of observation, which is mostly the ground frame, also called the inertial frame. Suppose in this figure, you need to draw the FBD of the box. First, let's consider the box to be a point mass. Here we have it. We label it as M, as the mass of the body. Next, we will mark all the forces that are being applied on the mass, on the box, which are the weight that is being applied by gravity on the box, which is W equal to mg. And next, we have the normal reaction that is being applied by the wedge on the box in this direction, which is again perpendicular to the point of contact, and the normal reaction is N. So we have mg in downwards direction and a normal reaction N in this direction. Here we have the FBD. In this figure, we have a pulley. Let's mark all the forces first. So on both the masses, we have weights, that is M1 into G acting downwards and M2 into G acting downwards. Then we have a string. So we mark tension T away from the masses on either sides. T in this direction and T in this direction. Also, the same tension T is being applied on both the sides of the pulley away from it. Here, the tension remains the same because there is only one string that is being used. Also, a tension T1 is being applied in this direction, and this string is attaching the pulley with the ceiling. Now, let's draw the FBD of the pulley. First, let's make a point mass P and two tensions T on both the sides and a tension T1 on the upper string. For the mass M1, its respective M1G downwards and a tension T in upwards direction. For the mass M2, we have the same M2G, the weight in downwards direction, and a tension T in upwards direction. Now, let's dive into the actual chapter with Newton's first law of motion. This law states objects in motion will stay in motion and objects at rest will stay at rest unless acted upon by an unbalanced force. This means if an object is in rest, it will stay at rest until and unless we push it or an unbalanced external force is applied on it. And a body in constant motion at constant velocity will stay in the same state until and unless an external force is applied on it. Now, let's try a question. Tensions in both the strings. The system is considered to be in equilibrium. So, first we need to make the FBDs for both the boxes. For 2 kg, let's make a point mass 2 kg and the forces acting upon it are the weight of it, which is M1 into G. M1 is 2 kg and G is taken to be 10. So we get 20 newtons. A separate force is acted upon it by this string, which is tension T1. Also, this string acts as tension T2. For 5 kg, we make a point mass 5 kg and a downward force, which is the weight, which is 5 into 10, m into g, which is 50 newtons. A separate force by this string again, we get it as T2. So balancing out the forces, we get T2 is equals to 50 newtons. And for the first box, the equation we get it is T1, which is in upward direction, is equals to T2, which is in downward direction, plus 20 newtons, which is again in downwards direction. So from equation 1, we put the value of T2 in equation 2. So we get T1 is equals to 50 plus 20 newtons, which is 70 newtons. So T1 comes out to be 70 newtons. We hope that you have understood the concept. Now, here's a secret on how you can study effectively with the EduRev app. You can learn with chapter notes, watch video lectures, and solve JEE level MCQ tests of this chapter on EduRev. And that's not all. You also get amazing courses for mathematics and much more for your JEE preparation.